Okay, the last section we're going to talk about before we start graphing these rational functions and polynomials is the roots. Okay, so a root is where the graph crosses the x-axis. Okay, it's where the graph equals 0. So we're looking to find when the equation equals 0. Okay, so first of all, visually, we're going to look at it and talk about it in terms of multiplicity as well. So on this graph, we know that this equation equals 0 at -1. Okay, and this would be, oops, I've got it right in my pen. This would be at x equals -1. Okay, so this would be x equals -1. There's a root because here it crosses the x-axis at -1. Okay, here it touches the axis at 3, but it goes back up. So this would have a root at x equals 3. And it would have a multiplicity of 2. Okay, now it could also have a multiplicity of 4, but it has to have an even multiplicity. I'm going to have you just go ahead and assume that it's 2 when you're going off of graphs like this, okay? Okay, so it touches the graph and does not go through, so it would have to have an even number of multiplicity, okay? Then we look, okay, so it went through here, it touched here, and now it's going through here. So it also has a root at x equals 5. Okay, so visually, that is what it looks like, right? So visually, we can see it going through the x-axis. Okay, so now let's talk about roots a little bit more as well on the equation. So if you look at an equation of a function, you can tell how many complex roots there are by the largest power in the function. Okay, so let's talk about what the word complex means. Okay, what this means is that I think we've talked about in class that this is the largest amount of times that it would cross the x-axis is 4, because it could cross less. The reason it can cross less is because there are imaginary roots as well. Okay, so complex roots means that between the real and the imaginary, there are 4. It's just a matter of how many of them are real and how many of them are imaginary. Okay, so you don't actually have to worry about sorting that out yet. We will sort that out in the next unit. We're going to talk about imaginary numbers more. But this unit, we're just talking about real. So what I want you to first do on these notes, it says to list the number of complex roots. You are just saying that there are 4 complex roots. I do not need you to tell me the real and imaginary number. Okay, we're going to do that in the next section. So here, then it says find all the real roots. So how do we find roots? So first of all, let's change this color so you can tell what my... Okay, so first of all, you would say there are 4 complex roots. Okay. And then we're going to go through now and we're going to solve for it and find where it equals 0. Okay, so we're going to take, and we're going to set this equal to 0 first of all. Okay, so 0 equals the 2x to the 4th minus 8x squared. So we're going to be using some factoring skills. Now, if it's just a regular quadratic, you can try factoring it how you guys are used to. And that's something that you've practiced more and more is, what multiplies to give you the last number, adds to give you the middle number. That only works on a quadratic function that has 3 terms. Okay, so now we have a quartic one, raised to the 4th power, a 4th power function, a polynomial, and there's only 2 terms. Okay, so what's the first thing we do? We look for a common factor that can come out of both terms. Now in this case, we can pull out a 2x squared out of both terms. So I'm going to take a 2x squared. And that leaves me here with just x squared. So remember, when you divide it out, you're looking for, if I was to multiply these back together, it should equal that term, right? So 2x squared times x squared is 2x to the 4th. Okay, then we're going to factor out of this 8x, we would get 4. And we're here. Now, I did this one specifically for a reminder. I have a big reminder of a formula that you need to have memorized. Okay, difference of squares. Okay, so we have difference of squares. Okay, this is something that if you, at this point, you have to have this memorized and you need to be looking for chances to use it. Okay, so difference of squares says that if you have 2 perfect square numbers that are subtracted from each other, you can factor them. So this should be you should be as used to doing this as you are to doing your regular old, what multiplies to be the last number, adds to be the middle, is if they're perfect squares. X squared is a perfect square. You can take the square root of it and it's even. 4 is a perfect square. So we can take it and take the square root of each of the values and add and subtract them from each other. Okay, so let's get our regular color back here. So we're going to have, we still have our 2x squared. Write down everything. Do not leave things out when you're doing this. Rewrite it each time. So the square root of x squared is x. The square root of 4 is 2. So we take the square root of each of the numbers and do 1 added and 1 subtracted. Okay, now remember, this only works if they are subtracted. It's the difference of squares. They have to be subtracted and they have to be perfect squares. Okay, all right, so now we have this out in factors. What happens when you have an x squared that is you're supposed to have this as linear factors, right? So I'm going to separate this out. Most of you are getting a hang of this, but I'm just going to separate this out. We're going to factor out our x squared. So we're going to have 2 times x times x times x plus 2 times x minus 2. Okay, so the reason that I set this out together is because once you have your equation in linear factors, everything is multiplied out. If you multiply this all together, you get back to your original function, but everything is separated out into linear factors, meaning everything's raised to the power of 1. This 2, everything's multiplied together. You can divide both sides by 2, and 0 divided by 2 is 0. So this 2 it can be eliminated out in the way that, because we have it set it equals 0. Plus, right now you're going to set everything equal to 0, so you could keep the 2x, and you'll see that it'll come out here as well. You'd have 2x equals 0, divide both sides by 2, you still have x equals 0. Okay, so the 2, it gets eliminated because it's just out there by its lonesome. It can be divided out. So I'm going to x equals 0, x equals 0, x equals negative 2, because I'm going to set this whole thing equal to 0, and I'm going to subtract 2 from both sides to get x equals negative 2. And here I'm going to add 2 to both sides to get x equals positive 2. Okay, so now I have a x equals 0 with a multiplicity of 2. And here I have x equals negative 2 and x equals 2. So this is my 4 roots. Now remember, we said that from the beginning. We knew that there were going to be 4 roots. Now all of these happen to be real roots, and most of the assignment will be, because that's what we're focusing on in this assignment. Okay, let's look at another example. I want you to tell me how many complex roots there are in this function, and I want you to find them. Okay, so first of all, we're going to look, we're going to look and we're going to find that it has 3 complex roots. Okay, so it's going to have 3 roots. Actually, let me switch my color real quick here. Okay, so that's the first important thing, is you can tell by just looking at the equation as long as it's multiplied out. Now that's something to take note of, is it needs to be multiplied out the highest power when everything's multiplied together. So if you see it in factored form, you have to kind of multiply everything out, and I'll show you that in a second as well once we factor this out. Okay, so here we look for, first of all, it's not a quadratic. We know how to do a lot of things with quadratics. If it's not a quadratic, you have to look at other options. So we're going to set this equal to 0. And we're going to take this now, and I can factor an x out of everything, right? We look for that common factor that can come out of everything, because it's going to simplify things down, and now it's going to give us a quadratic, okay? So I'm going to take an x out of everything, and I have this left over here. Okay, now look, if you saw this in this form, you would have to say, oh, well, I have to multiply that in, so then the largest power would be x cubed, and you still have 3 roots, okay? Just something to note. Okay, so now we need to try and factor out our quadratic. Now, our quadratic, if you look at this and you try and factor it, the way that you probably are most comfortable with is you say, okay, what multiplies to give us -1 and adds to give us +2? Well, there isn't anything. And the reason that there isn't anything is because these are not whole numbers, right? And we can only do that when they're whole numbers, because you're not able to find fractions and radicals in your head. So we say, okay, so what is the next formula? You have to know. You have to know this, and you have to have it memorized. If you said quadratic formula, you're right. Woo, quadratic formula, okay? You have to know the quadratic formula. When you are stuck and you can't factor something by hand and you're looking at a quadratic, you are expected to factor it using the quadratic formula. Okay, so we're going to get rid of this. We still have this x on the outside, but we need to find the factors of this. So right now we know that x equals 0 from this term right here. Okay, now we need to find these other two factors by using the quadratic formula. The biggest mistakes I see in the quadratic formula are from pure laziness. You guys do not want to write everything out. You have to write everything out. Okay, so x equals negative b. We go here. This is a is 1, b is 2, c is negative 1. So we go negative b plus or minus the square root of b squared. So I have 2 squared minus 4 times a, which is 1, times c, all over 2 times a. Okay, now I want to point out there's also other mistakes that happen here. The first mistake that I see is inside the quadratic here, inside the radical, sorry, not the quadratic, inside here, this value, if it's positive or negative, you are always squaring that value. So you should always start by squaring the number here, and you should have a positive number as your first number under your radical. Always. You will always have a positive. Then I'm going to take my minus sign, and I'm going to take inside here, and I'm going to multiply these three numbers together. 4 times 1 times negative 4 is negative 4. Because the other mistake that I see all the time is that this gets multiplied together instead of added together. Okay, so now I'm going to do negative 2, and every time you're writing out the whole thing, if you try and skip steps, you will make mistakes, and then you'll get the wrong answer. And it just isn't, you have to just write it out. Okay, so this ends up as a positive 8 over 2. Okay, now 8 is not a perfect square, but 8 can be simplified. So we're going to take this, and we spent a lot of time on this, so hopefully you remember it, and if not, you need to ask me. This whole class is based off of saying, hey, I don't know how to do this, I'm going to learn how to do this. We have done it in class, so I'm not going to go over it a ton here, but we're going to say, okay, 8 is the same thing as 2 times 4. 4 is a perfect square, so when you take the square root of 8, I'm going to just take it out right here. I'll do it right here. Square root of 8 is the same thing as the square root of 2 times 4. The square root of 4 is 2. So if I take the square root, because like having the square root of 2 times the square root of 4, if I take the square root of 4, it gives me 2. And now the square root's gone because I've taken the square root of it. So this becomes 2, and then I still have my square root of 2. So if you have any questions about where that comes from, you need to ask me, okay? So then we get 2 square root of 2. It's the same thing as 8, the square root of 8, all over 2. Okay, so now we're going to take and simplify. If you notice, you have to take and divide both of these terms by 2. So we're going to have negative 2 divided by 2, which is negative 1, plus or minus 2, square root 2 divided by 2, which is just the square root of 2. Okay, so this means that these other roots are x equals negative 1 plus the square root of 2, and x equals negative 1 minus the square root of 2. Okay, all right, so now you have 3 roots. These are your 3 roots. There's no multiplicity, and we are set. So I went through a couple other factoring things. Went through this. Okay, oh yeah, one more thing. Let's do one more thing. Okay, I think there's a lot of question about how to find roots of a rational function. Okay, so now it looks different, right? Because we have now things on top and the bottom. What is this value on the bottom? Okay, the value on the bottom tells you where the vertical asymptotes are. The vertical asymptotes are not the same as roots. A vertical asymptote is where it's undefined. It's undefined on that entire thing, where a root is where it equals 0. Being undefined and equaling 0 are two very different things. Okay, something can equal 0. Undefined is when this asymptote is created because it's not defined at that point at all. Okay, so what I want to point out, let's go to this side here. If I was going to solve the equation y equals, actually let's do this better. If I want to get rid of something in the denominator, for instance, okay, so I'm going to say, instead of that, I'm going to do 10 equals x over 3, okay? And better yet, we'll just do 0. Sorry, I know I keep changing it. Okay, so let's say 0 equals x over 3. If I want to solve this, then I'm going to get rid of this denominator, right? And I'm going to multiply by 3. And then on this side, I will multiply by 3. Well, what is 3 times 0? Still 0. And over here, we just get x, right? So we could multiply by that denominator on both sides when it equals 0. Okay, so what happens is here, we're going to factor everything out and make it look all nice so we can see if there's any holes. We can see if there's any vertical asymptotes. So this is already a linear factor. Okay, it's already written as a linear factor. Here, we're going to write this out as linear factors. Okay, by saying, okay, what multiplies to give you 10? And, oh, this is a really bad example. Oh my gosh, guys. Okay, turn this to a 3 for me, just for so I can actually illustrate what I'm trying to illustrate to you. Sorry, I usually try and choose them before. Okay, so then here, we're going to go through and we're going to factor. What multiplies to give you negative 10 and adds to give you negative 3? Well, you have to you say, okay, 5 and 2. Okay, so negative 5 and positive 2. Some of you are saying, oh, I see why. I didn't want to create a hole. I accidentally created a hole. Okay, so now there's no holes. There's no vertical asymptotes. So the numerator is going to show us where it crosses the x-axis, where it equals 0. The denominator, when the denominator equals 0, that's going to show us where vertical asymptotes are. So right now I can tell you there's a vertical asymptote at x equals negative 3. Now I need to set the entire thing equal to 0. I need to know when y equals 0 to know when it is when it has vertical asymptotes. So here I set it equal to 0, and I need to get rid of this denominator. This denominator isn't a 0. Remember, this is just what causes it to be undefined. So I'm going to multiply both sides by x plus 3. Okay, and what you're not going to have to do this every time. I'm just trying to show you that then this times 0 is 0. And you are left with x minus 5. And this is kind of, I'm trying to decide if this is a good example or a bad example, honestly. What I want to show you is that really you need to get it down to where you have just your numerator equal to 0. Those values on top are what create zeros. The values on the bottom create undefined points. So if we can cancel those out by multiplying them out, we're then just left with the numerator. I'm questioning how much math stance that has right now. But hopefully that kind of helps you see that it's, yeah, so let me just reiterate that one more time. The denominator, so I'm going to go back to here. The denominator tells us where it is undefined. Okay, so I'm going to give you this point. Right, this is the vertical asymptotes. This is where it's undefined. So if this is the vertical asymptotes, these are the zeros. And that is what we're looking for when we're looking for the root, okay? It wants to know where does it equal 0, not where it's undefined, where it equals 0. So this would equal 0 at x equals 5 and x equals negative 2, okay? Okay, so you're going to be asked to use this to find roots. You need to find the roots And then you're also going to do some review of finding vertical asymptotes and horizontal asymptotes. We'll see you in class.